I'm audible?
Yes, sir.
Okay, yeah, thank you. I will wait for 5 minutes and then we can start.
Sir, may I know today what are we going to discuss, sir?
Week 9 practice assignment questions are pending, so we'll discuss that. And next week is completely quiz 2 revision, okay?
Okay, okay, sir.
I think we can start now. So, hello everyone. So,
Good
today
evening,
we are
sir.
going to discuss, yeah, good evening. So, we'll discuss week 9 practice assignment question today. And next week we'll have practice, no, not practice, quiz 2 revision session, okay? And we'll release mock test also on Monday for quiz 2. Let
The
us,
city mock test will be graded.
no, not graded, but you have to attempt that, okay?
Yes, sir. I will already
Yeah.
attempt the quiz one mock test and definitely I will attend quiz two. Okay.
So, let me share my screen. So, in week 9, we are focusing on graph part, right? So graph and the matrix. What? Yeah. So we already released the week 9 solution, practice assignment solution. So this is question number 1 here, right? But before that, I hope you know the concept of adjacency matrix. Adjacency matrix. Suppose I have a graph like this. I have a node A, node B, C, let's say D, and I have E here. Okay. So this is basically my graph. And here if you see, I have a two node A and B. If arrow is like that, it means that I can go from A to B, not B to A, right? That is basically directed graph. So whenever we have an arrow, that is basically a directed graph. It means we can traverse in a particular direction from A to B, not B to A. So this is basically a directed graph. When I say A, simple line, B, we don't have any arrow here. That is basically undirected graph. It means that I can traverse in both the way. I can go from A to B as well as B to A, right? So both the things are possible here. In the case of undirected graph, that is basically directed graph. I can only go from A to B, not B to A. Okay, so this is about directed and undirected graph. And we can represent this particular graph in the form of matrix, and we call it as adjacency matrix of this particular graph G. Okay, and how we formulate this? So how many nodes we have? 1, 2, 3, 4, 5. So here n equals to 5. 5 nodes we have. So it will be a 5 by 5 square matrix. So for A, B, C, D, E, and here let's say A, B, C, D, E. So that is basically 5 by 5 matrix, right? Now, what are the element of this particular matrix? So here you can see when I say this is basically my row and this is basically my column, right? So when I say A, right? So this particular element. So can I go from A to A here? No, right?
No, sir.
We don't have any this particular type of thing. It is a called as loop here. Here you can see this. If age is like this, it basically means I can go from A to A, but it is not there. So it will be a 0. What about, so first we are discussing about the node, this particular A. From A, where I can go? Can I go to A? No. Can I go to B from A?
Yes, sir.
Yes. So whenever there is age from node A to node B, we represent that by 1 here. Okay. So we represent generally age by 1. So I can go from A to B, so that's why 1 is there. What about A to C? Can I go A to C?
Yes, sir.
Yes. So here you can see we have a H, A to C. I can go A to C. That is basically 1 again. Can I go A to D directly? Do we have H, A to D?
No.
No. So that will be 0. Similarly
No.
for E also, that will be 0. Okay. Now, what about B? From B to A, can I go B to A?
No.
No.
No, sir.
Again, B to B, 0. What about B to C? No.
No, sir.
B to D? Yes. D to E? Yes.
Yes.
Similarly for C, C to A? No. C to B? No. C to C? No. What about C to D?
Yes.
C to E? No. Right?
No.
Then we have D and E. From D, where I can go? I cannot go to A. I cannot go to B. C also no. D also no. Only E. What about E?
Nowhere we can go.
No. Right? That's it. So this is basically adjacency matrix of this particular given graph G. Okay. So whenever we say there is age from node A to B, and if I represent this particular matrix by say M, so I will represent like this: M in square bracket A in square bracket B equals to 1. It means that for a matrix M, in a matrix M, for a row A and column B, so row A, column B, it is equals to 1. It means that there is a age from A to B. Okay. This what this representation mean. Anyone any doubt in about the graph and the adjacency matrix?
So here, if your M, A, and B equal to 1. If not mentioned means is understood by 0.
Yeah, if there is no h from A to B, so that will be 0.
Which is not mentioned.
Yeah, but I can go from A to B. So if I talk about it's what about AE? So if I write like this, M of AE,
0.
that will be 0. Okay. There is no h from
Okay.
A to E directly, right?
Okay.
So this is
Got
the adjacency matrix for this given graph. Okay. So you
Sir,
should know how to draw this particular matrix if graph is
Mhm.
given to you, or you should also know if a matrix is given to me, can I convert to the graph? Okay. So both the things are
Oh,
possible.
okay. Got it.
Yeah. And this matrix will be always a square matrix of n by n. Remember this point as well. Okay, great. So if you understand this, let us discuss the first question here. So consider the following graph generated from the scores table. Each node in this graph corresponds to a student from the table. So each node in a particular graph corresponds to a student from the table, right? So there is an age between two nodes if the difference between the physics marks of the corresponding student is at most 5. Let's say I have a one node I have another node J. There is age between I to J like this. If the difference in the physics marks of the student I and the physics marks of the student J is at most 5, right? So difference between the marks of this student is at most 5. Then there is a age between I to J. At most means what? 0 to 5. Okay. Now the graph is represented by the matrix A. Sequence number is used to label the nodes in the graph. So if you observe the scores data set, we have sequence number as a column like 1, 2, 3 like this. So in the graph, it will represent like this 1, 2, 3, 4. So nodes in the graph is basically a sequence number. So it is used to label the nodes in the graph. Okay, so it represents the student. Following pseudocode computes the matrix A. Select the correct code fragment to complete it. And what is our requirement? There should be age between the two nodes if the difference is at most 5 and the physics marks. Okay. So let's discuss this pseudocode. Here I have a marks one variable which is basically read physics marks. We have a procedure for that. So let's go to this procedure here. Read physics marks. Marks is basically what? Empty dictionary like this. So what we are doing, while table 1 has more rows, read the first row X in table 1. So if you observe the scores data set, our first row will be the first sequence number, then the name, then the corresponding physics, chemistry, mathematics, and total marks is there, right? Read the first row, marks, sequence number. So here if you see marks is basically dictionary. Now what does this particular line mean? Yes, anyone?
sir, it's storing the physics marks for that particular sequence number.
Yeah. So
Is that
sequence
but
number will be the
key
key. The
Sequence
corresponding
number
value
mapped
will
to
be
the
physics marks,
corresponding
physics mark?
physics marks.
right? And then we are moving that to a table 2, and this we are doing for all the rows from this particular scores table. So marks is like this. So here if sequence number is 1, suppose marks is 17 physics, so that will be like this. Sequence number is 2, marks will be 60
Mm.
like this.
Yeah.
Sequence number is 3, marks will be 65. Sequence number 4, marks will be 70 like this. Okay. So in this way we will have how many sequence number we have in scores table? If you observe, we have 30
30.
rows.
30.
So in this way, we will have 30 sequence number and the corresponding physics marks in the marks dictionary. So this is what we got from the procedure. Now here marks is basically what? This particular dictionary. Now n is what? Length of keys of marks. So what is marks dictionary? Keys of marks is basically what? List of
List.
keys, right?
L-
List of keys. So that will be like this 1 comma 2 comma till 30 for sequence number, right?
Yes, sir.
What about the length function? Length will simply count the number of element in
Element.
the list. So that is what 30. If I
Yes,
have
sir.
30 rows, if I consider this particular dictionary here 1, 2, 3, 4. So in this case that will be 4 because here list of the keys is 1, 2, 3, 4 and number of elements are 4. So in this case 4. But if we talk about the scores table, that will be a 30. and we need to fill the code to find out this particular requirement. Okay, so this pseudocode is given to us and we need to fill the code. Now just go through option wise. So we already know n, that is 30. So we are creating a matrix A, that is n by n, that is basically 30 by 30 matrix we already created. For each I in keys of marks. So keys of marks, again a list of the keys. Let's say for example 1, 2, 3, 4. For j in keys of marks, again same thing, same list 1, 2, 3, 4, right? So for the outer for loop, what we are doing, for each I in keys marks, for the first iteration, I will be equals to 1. For each j in keys marks, for the first iteration, j will be equals to 1. So we are talking about if condition here. If minus 5 less than equals to marks of I minus marks of j. But here if you observe, I and j, that is 1 comma 1. So 1 and 1
Sir,
here.
here 1, 2, 3, 4 are sequence number of the card.
Sequence number of the, yes, student, yeah, card. So this is what it is saying here, right? Sequence number is used to
None.
label the node.
So when you explained it's at most 5, it is
Hmm.
plus or minus 5. I mean, from below 5 or maximum 5.
0 to 5. At most 5 means 0 to 5. But we are
Okay,
taking a
okay.
difference. So either this
Mhm.
can be 65 minus 68 will be minus 3, but that is anyway 0 to 3. So difference is we are considering here, right? Difference can be
Okay.
negative here. So that's why we are considering minus 5. So what will happen here? Marks of I and also 1 here. So both the marks is basically a same thing, right? So here I and j both are the 1 only. So that anyway this will give me a 0. And anyway for I and 1, so I and j both are 1. So anyway we will have 1 for the corresponding row or column for 1, right? Then if we go for a next one, next means what? This particular thing, j equals to 2.
2.
Now again we are comparing marks I and j is 2. So if you go here 70, it is 60. So 70 minus 60 is what? 10.
10.
That is not satisfying. So no, go for next iteration. J equals to 3. That is what? 65 for j. So this is 70, this is 65. Difference is minus 5, satisfying this particular condition. And then we are saying it is equals to 1. We are equals to 1 means what? There is age from I to j. So this is again satisfied. Go for next iteration. So in this way, are we going to get the required thing? Can I say there is age from I to j if the difference is at most 5,
Yeah,
right? So
correct.
this is the correct one, right? Because here difference is at most 5. And we are talking
Mhm.
about
Yes,
this
sir.
one. We are not taking absolute value here. Mod is not given to me. If I put this inside the mod, then that will be even though in that case also it will be correct one, right? Because anyway that this cannot be negative. So here you can see minus 5 to 5 because we have not mentioned the mod. So anyway, difference is getting considered here. So option A is correct here.
Sir,
Huh?
sir, if this inner if condition fails, it will
Hmm.
automatically entry that value to 0
Yeah. So
in the
when we create
matrix.
the matrix now, so automatically for all the field 30 rows, 30 column, everything is 0. Okay.
Yes, sir. Yes.
And then we are updating it to
Initially, it
1.
will be zero now, sir.
Yes,
Yes,
initially it
sir.
will be
Yes.
0. Yeah. So this
So
is
we
what
need
A
not
create
update again.
matrix. No, no. So n by n, when we create this matrix, so all the value,
Initially,
it will be 0 only.
okay, sir.
And then we are updating that particular value here. Okay.
Okay, sir. Okay, sir.
Yeah. So option A is correct here. If you look at option number B, everything is same, but equal to sign is missing. Okay. So at
Yeah.
most we want. So 5 is also considered. That's why option B is not correct. Now if you go for option number C,
Here also
Uh,
equal to sign is
No.
absent.
Create a matrix is not given, sir.
yeah,
That's
we
one
have
of the
not
main
created
mistake.
the matrix also here. So since matrix is not created, we cannot check this condition. And anyway, equal to sign is also missing. So anyway, option C is not correct. What about option
uh,
number D?
So here 0 is present, but difference can be negative.
Yes, sir. Difference can be negative.
Yeah.
no, actually, the thing is, what I understand here. So that
Hmm.
if a student is when you're comparing with 70, it can
Hmm.
be 75 also and it can be 65 also. Then
Yeah.
it can be updated. So from that's what I said. From below also and above also 5 marks at most it is counting.
So we are talking the difference only here. So if it is has 65 and this has 70, so that will be -5, right? So we
Yes,
Uh,
consider
sir.
difference in 5, so this should be considered. But it is not going to consider that thing, right?
yeah.
So option D is not correct. So this will be correct if I put inside the mod. Okay.
We have to
Mhm.
take absolute values, sir.
Yeah, absolute
Then it
value.
will.
Yeah.
Yeah.
So in that scenario, this will be correct, but this is not there. So option D is also not correct. So that's it. Option A is correct. Anyone, any doubt in this question? No? Okay. So second question, second to fourth. So let's discuss this. Consider the following table in the scores of n student in a class. Assume that all scores are between 0 to 100. The scores in the first and the last row are shown in the example. So sequence number is given to us, scores is given to us out of sorry 100. The actual score might be different, so we have to refer only to a scores header to answer all the question. Okay. The information is stored in a dictionary S. S is basically dictionary with the serial number as a key and the corresponding score as a value. So S is representing this particular table. In a such a way, the corresponding serial number is given to as a key and the value will be what? 50 here, corresponding scores. Similarly, like this. So let's consider one demo table here. We have serial number, we have score 0, 1, 2, 3, 4, 5. Score say 50, 60, 80, 55, 40, 58. Okay. So this is serial number. This is basically score. For demo purpose, we are considering this. And S is a dictionary created based on this particular table. So S will be like this. So key will be 0. Corresponding value will be score 50. Here 1, 60, 2, 80, 3, 55, 4, 40, and 5 basically 58. So we have to do this for all the things, but I'm just saying here n is what? 6 here. So we are considering n equals to 6 for this case. We have 6 rows here, and this will be the dictionary. Okay. Now we have graph G generated from this table in the following manner. So we are generating a graph in this particular manner. Given a pair of student I, J, is age from I to J if and only if I is strictly greater than that of J. If the scores of I is greater than of J, in that scenario, I can say there is an age from I to J. So remember this point. The graph is represented by matrix A. Assume that the dictionary S has already been computed. So we have already calculated. Now study the following pseudocode. Okay. Anyone, any doubt in the question? You understand why we have done this, right? Dictionary S. Okay. So let's go through this pseudocode. N is what length of the keys. Keys is basically, so let's take this demo example only here. So we have 6 row. So it will be a list of 6 elements 0, 1, 2, 3, 4, 5, and length is basically 6. So n equals to 6. A is create matrix. So we have matrix of 6 by 6. All are basically 0 initially. So let's do that also. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So initially all are 0. Consider each for each R in rows of A. Rows of A means what? This particular thing 0, 1, 2, 3, 4, 5. For each C in columns of A, again same thing. It will give me list of rows number. It will give me list of column number. So same 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5 like this. If S of R greater than S of C, then we are going to update this particular dictionary, sorry, not dictionary, matrix. So initially we start with 0. So R equals to 0 for the first iteration. C is also equals to 0. So if I take a 0, 0, we cannot compare the same thing. So anyway, 50 is not greater than 50. So that will not going to update. So we go for a next iteration. So this will be 0, right? So outer R is fixed for the inner iteration, right? So R will be 0 only for all the values of inner for loop, right? I'm going to update the value of C now. Now C is equals to 1. So here 1, this is basically 50 only. Now what is 1 value? Serial number 1. S of 1 is 60. 50 greater than 60? No. Go for
Yes.
next iteration. Second verse will be C here.
Okay, okay.
Yeah.
Sir,
80.
sorry, sir.
Huh?
The thing is actually it is checking by the it fix the row and
Hmm.
then checking with every column or else or
We have fixed
it
the
is
row and now we are checking by this column name.
okay, okay,
That is what of outer for loop is doing. So for R equals to 0, we are comparing all the values in the column first.
okay,
Then we will go for a next row like this.
okay. So fix the
So
50 and checking every column.
yeah, because R is 0, so S of R is 50, right? S of
Okay,
0.
okay.
So S now second iteration, third iteration is C equals to 2 is what 80, not greater than 50. Go for next iteration. C equals to 3. 55 again 55 not greater than 50 is not greater than 55. Go for next iteration. Now here C equals to 4. So here I got the value C equals to 4. And what is S of 4? 40, right? Now
Yeah.
here if you observe 50 is greater than 40, so R is 0, C is 4. In this particular matrix, 0th row, 4th column will be updated to 1. Rest all will be
Correct.
0. Now go for next iteration. C equals to 5, 58. Again 50 is not greater than 58, so that's it. So this is the first row. Then once we're done with inner for loop, if you see, we don't have any other element to go through. All the 6 elements are considered, right? So we don't have anything in the list. So list is empty now. We've already traversed to all the list. So we will exit the for loop and we will go for outer for loop now. Here I'm going to update the value of 0 to next 1. Now same thing, what we have done for the 0th row. So we have to consider first row and compare with all the marks. So here we have fixed the R. Then again we are comparing with this one. So here R is one like this 60, and then we are comparing this one. So first we start with 0, so equals to 0.
Yes.
So yeah, so I will quickly do this. 60 greater than 50. Yes,
50.
that is
Yeah.
true, right? So that will
Yeah.
be 1.
1.
1 greater than
0.
1, no. 0. Again to 80. 60 greater than 80,
0.
no. 60 greater than 55, yes.
Yes.
60 greater than 40, yes. 60 greater than
Yes.
58, yes.
Yes.
That's how my first row will look like. Go for a next
Yeah.
iteration. Value will be 2. You understand what I'm doing here, right? So I'm going a little
Yes,
bit
sir.
faster now for all the rows. Okay. So now see. So for second, R equals to 2. For zeroth, so what is second here? 80. So here I have fixed S of R, that is S of 2 is 80. So 80 greater than 50, yes. 80 greater than 60, yes. 80 greater than 80, no. 80 greater than 55, yes. Greater than all the values, right? So 80 is the highest one. So except the second one, it will be greater than for all the things, right?
Yes.
Yeah. So tell me one thing, if for highest value, except the same node, we are getting 1 1 for all the uh, rows, for all the columns, what will happen for a lowest value?
Ex except that column, everything will be 0. No, everything 0 only.
Everything
Everything
is
zero,
zero.
sir.
Yeah,
Uh-huh.
so let's discuss that. That will be our node 4, right? Because against 40 is the lowest one. Yeah, so we'll check that. So here 1 0 1 2 3 is right. Now the next iteration R is basically 3. So we have fixed the 3 to 55. Now 55 greater than 50, yes. 60 greater than 55, yes, yes. This is 0, this is 0, and sorry, this will be 1. 55 greater than 40, 55 greater than 80, 58, no. Now we'll go for a fourth here. Now see what is happening here. Now next iteration, R is basically
Sir,
Fourth, huh?
third row, fourth column is 0, na? Because 55 less than 80.
No. Third row, fourth column is 40, right? So 55 greater than 40.
Sir, and
Sorry.
the third
Second one.
row,
Yeah,
first
second row.
column also, sir.
Oh, okay, this will be 0, right?
No,
This
sir,
will,
third row, first column. That means
First column also now.
yeah.
40.
yes, 60. Yeah, this one, right? Third row 0 will be 55 greater than 50, that is 1. 55 greater than 60, 0. 55 greater than 80, no, 0. 55 greater than 55, no. Now this is correct, right?
Now this is correct.
Yeah, this correct. Yeah.
Okay, yeah. Now go for a next iteration, 4. So 4 is what? 40 here. Now 40 greater than 50, no.
Everything
40 greater
0.
than 60, no, 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 and no. So if you observe here for the lowest value, we have all 0, right? Because anyway, this condition will not get satisfied there. Now what
The
about the
last one
last?
is 58, na? Last one.
Yeah, so 40 is not greater than 58, right?
Hmm.
So we'll consider that now for the last element when C equals to 5. Now, sorry, R equals to 5, that is 58. Now 58 greater than first one is 50.
1,
Yes, 0, 0, 1,
1,
1, 0, right?
0. Hmm.
Now this is what we got from this particular pseudocode, right? This is our matrix A. Now this is the question given to us. Now let's try to solve the question. Anyone, any doubt what we have done here? This
No,
is
sir.
No,
clear,
sir.
right? Okay. So for row R of matrix has three entries that are equal to 1 and the rest are 0. So they are saying we have particular row for which we have three entries equal to 1 and the rest are 0. Which of the following statements about the student R is true? So do we have any row? We have three entries equals to 1.
Fifth row,
Third,
sir.
Fifth row.
fifth row, right? So here you can see. Now let's discuss about this particular row. So there are exactly three students who have scored more than the student R. Is this correct?
No, sir.
There are exactly three students
No,
who
no.
has scored less than student R, right? It should
Yes,
be
sir.
less
Yeah.
Yes, sir. Yes,
Yes,
sir.
sir. Less.
because here you can see R is there, so R is greater, right? So that will be a less. So A is not correct. There are at least three students who have scored less than R. Can I say at least three?
No, sir.
No, at least.
Strictly.
No, at
Exactly.
least. Exactly. Yeah.
So exactly three who have scored less than R. C or equal to R. No, equal to is not
No,
considered in
no.
the condition, not correct. So option C is correct here, right? Any doubt in
Yeah.
question
Sir,
number 2?
option D and option B are same, right? Can we say?
No, here less than or equal to is given. No? Exactly 3 and at least 3 is there. Is less than here, less than or equal to is there, right? So different.
Sir,
Okay,
actually,
sir.
they in the question they ask us to take only 5 students or what? Yeah, I seen
No.
only n. Uh-huh. How many
So
students we supposed to take?
they have given the table, it is n minus 1. It depends on us, okay?
Mm-hmm.
But if you see for such type of question, better they ask for 3 students, so we should take more than 3, right?
Okay.
As a demo thing, yeah. But even if you didn't take consider this particular matrix, still you can solve this question simply if you understand what we
The
are
code,
doing
yeah.
here. Yeah, what we are doing here when it is equals to 1, simply when this condition is true, right?
True.
That's it.
Correct.
So that matrix is just for our example purpose. Even without that, you can solve the questions. Yeah. So let's go for question number 3. If R and C are two students with unequal score, so their marks are different. Which of the following statements are true? It is a MSQ question. So unequal score, right? So it can be greater, it can be less, but not equal. If R and C is equals to 1, then CR is also 1. Is this correct?
No,
No,
sir.
sir.
Oh no,
No, because when
because
I
it's
said
unequal.
so S of R, S of C is equals to 1. If this is possible when the R is greater than 1.
Greater
Sorry.
than C.
Yeah. So it doesn't mean that C greater than 1 is also 1, right? No.
Correct.
So it is not correct. What about P?
Yeah, that is
Yes,
true.
sir. It
Correct,
is
sir.
true,
It is
sir.
true. If the max of R is greater than C, it means that it is equals to 1 and this will be 0.
Yes, sir.
Yes, B is
Yeah,
correct.
correct.
What about C?
C also
True,
correct.
sir.
Reverse
Correct,
of
sir.
B only, same thing.
Uh-huh.
So C is also correct because we are saying unequal. So yes, that is also correct. What about D? Then there is insufficient information? No,
No.
right? We already know if there is equals to 1 from this code, it
Yes.
means that this is only possible when the marks of that particular student R is greater than this, then only it is equals to
C.
1. Right? So that's it. So option B and C is correct. Anyone any doubt in this question? No. So here also if you see, we don't require this matrix, right? So
Yeah,
let's
we
go
don't
for
want.
question number 4 here.
Sir, when
Yep.
will you start the revision session, sir, for quiz 2?
Next week.
Next week. Okay, sir. Sir,
Which
is
of the
the syllabus is from week 1 to 8?
week 1 to 8, but focus will be more on week 5 to 8, okay? So you can expect 80% week 5 to 8, 20% week 1 to 8. Work 1 to 5, 4 like this.
Total
Thank
how
you.
many questions?
Around 12 to 14 question. So
Okay.
14 question you can expect, yeah. 12 to 14. Okay, let's discuss this first. Which of the following statement about the matrix A is true? There is at least one row that has only ones in it. Is it true?
No, sir.
No, sir.
It can never
No.
be happen.
Itself, it will
Because
be
No,
zero.
no.
even if we have a
Both one is
maximum
0.
value for that particular row and same column, it is 0, right here,
Yes, sir. Yes.
because of this condition. If it is greater than or equal to, in that scenario it will be 1, right? But that is not there. So A is not correct. If there is at least one row that has only zeros in it, yes,
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir.
Minimum
Least
always have
value.
value.
that. Yeah. What about C? There's at least one column that has only ones in it.
No,
No,
sir.
no, same, no.
What is that? At least one column, one in.
That has only ones in it. That is also not possible. There's at least one column has 0 in it. Yes, here you can see. So
सर ये
when
फोर्थ वाला समझा नहीं सर.
Yeah, fourth one is at least one is 0. Yeah.
कौन सा ऑप्शन नहीं समझा? बी वाला. See, option A is
C,
what
C.
saying there is at least one row that has only ones in it. That is not there because if you see this particular condition, it is greater than thing. It is not equals to, means for a thing which is greater highest marks. If you see about the second one, that is 80 here, this highest. So we have one for every column, but not for itself, right? Because anyway it is greater than, not, it is not greater than 80 here. So here you can see we don't have any row having ones in it. So option A is not correct. What about option number B? There is at least one row that has only zeros in it. Yes, that is true because we have one score which is less than all the rows, all the scores, and for that particular sequence number we have zeros. So this is what it is, right? So all the, like in a row, all the element will be 0 for the sequence number having the lowest marks. Okay. What about
Sir,
this?
sir, option.
Excuse
Sorry.
me, sir.
Call. Sir, row
Yes.
number 3. Row number 3, fourth column is it 1, right, sir? It is
Row
1, right?
number 3, 4, yeah, 1. Yes,
Okay, sir.
this is 1. Yeah. What
Sir,
about
and the
this second
third
column?
option,
Third option. Yes.
sir,
Yeah.
like the data, we actually assumed all the values by ourselves. So is it necessary that there will always be one value that will be like, it is not necessary, that there will be one value which will be less than.
No, see, if you take any value, there will be always one value which is less than all the values, right? Even if you take duplicate of this, so it will be 40 here as well, right? So anyway, one value will be always greater, one value will be less, right? Take any example.
Okay.
Even if you take just three values, 50, 80, 40, so this is less, this is bigger. Even if you take repetition
Yes.
of this, so this is larger, this is smaller, right?
Okay, so in this case, when we take duplicates, actually this was what I wanted, that if we take duplicates also, so there'll be two values. So in this way, we'll have two rows which will have zeros.
Yeah, two rows we will have zero. That is correct. So what that's what we have said, at least, at least, at least. Right?
Okay, yes, sir.
So there is at least one column that has only ones in it. There is at least one row that has zero in it. So we already discussed option number B. What about option number C? Why it is not correct? At least one
So
column that has
diagonal value are always 0.
yeah, diagonal values are always zero. That is correct. So that's why anyway this will not be a correct one. What about D? There's at least one column that has only zeros in it. Yes,
Yes, sir.
if you
Highest
see
value.
highest value here, right? So here
Yes,
you
sir.
can see this particular thing. Okay, so that is also correct. If we have two highest value, there will be two such rows, right? If I just take 80, 82 times for a different sequence number, that's why we mentioned at least here. So option D is also correct. So correct is B and D. Anyone, any doubt in this question? 2, 3, 4. And if you observe, if you understand the code, this matrix is not required, okay? But I think for question number 4, it will be easier for you if you draw that particular matrix, right? For this question. But for
Question
question
number
2 and
4,
3,
we need it.
yeah, question number 4, you need it, right?
Yes,
Okay,
yes.
but even if you
Yes,
don't
sir.
draw that, still you can answer this question.
Like for visualization, it would be very difficult, sir.
Yeah,
For like in exam
yeah.
pressure,
In
we
exam, it
can't
will
be.
be difficult, right?
Yes, sir.
Okay, great. So this is about question number 2, 3, 4. Question number 5 to 8. Okay. So continuing with the previous question only. Assume that the matrix A has been computed. So let us take the same matrix here. So that we already calculated. Uh, let's see the question first. N is the length of the keys. So we consider 6 elements. So N is basically 6. K is 0. Sum score S of K. So S of K is what? First, like score of a student whose sequence number is 0, right? Wait, what is S here? Yeah, dictionary what we considered. It's
55.
linked to this particular thing.
50.
Okay. So let me
Yeah.
write the
Sequence
dictionary
number.
here. Yeah, sequence number here. So 0 is what? 50. 1 is 60, 80, 55, 40, and this was, I guess, 58, right? Huh.
Yeah.
60, 80, 55, 40, 58. 60, 80, 45, 50. What is this? 80. I forgot again. 80, 55, 40. 55, 40, and then this is 55, this is 40, and this is 58. Yeah, this is our dictionary. And if you see this one, S of 0 is what? 50 here. Walk initialized to true, hope equals to 0. So in the week, we have discussed about one hope, two hope. What is hope? What do you understand by hope? Yes, anyone? Okay. Let's discuss this question and then you can understand. So here, while walk is basically true. So while is true, walk equals to false. We have set walk to false for each C in columns A. A is what? 0, 1, 2, 3, 4, 5. If K is, we already fixed the value of K to 0 and we are simply iterating over the value of C. If 0 and that C is equals to 1, then we are replacing K equals to C. Okay. So here we need that matrix as well. So We cannot take the screenshot and copy paste here, right?
Sir, can I tell like if you want, I'll tell the values, sir.
No, I want for matrix only.
From YouTube, I'll go back and see, and you write the matrix if you if
Better.
it's okay.
I will take the screenshot here.
Okay, sir.
But that will not be visible for you. Let's continue. So for each C, so value of C is what? 0 here in column A. A is basically list 0, 1, 2, 3, 4, 5. K is what? 0 initially. C is 0. So if you see 0, 0, we have 0, right? We don't have 1 for this. So that is 0. So that is not true. So we are not going to do anything with this. Go for next iteration. Next, C is equals to 1. Now, do we have C 0, 1? You can check this dictionary here. So condition was S of R greater than S of C, then only it was equals to 1. Okay. So A R C equals to 1. So what this particular condition is saying? Is that true? The value in the zeroth sequence number is greater than 60? No, that is also not correct. Right? We don't have
Yes.
1 for that. So if you observe that matrix, we don't have a 1. So that will be a 0. I'm pasting the matrix in the chart. If you want, you can refer to that. Okay. So here, now K, that is not true. Go for again C equals to 1. Again, this is not true. Go for next iteration. Value of C is what? 2. So 2 is 80. That is also 0. Go for next iteration. Value of C is 3. 3 is 55, not greater than 50. Go for C equals to 4. If you observe here, C is basically 4. So when
Yes.
C equals to 4, the value is 40. And in the matrix for this particular thing, 0th row, 4th column, we have 1. Now here our condition becomes true. So our condition becomes true here. If the condition becomes true, what we are saying, K equals to C. What is C here? 4. Now sum score is what? We are updating sum score to the value of that particular thing. That is S of 4 is what? 40. So that will be 40. Walk is initialized to true. And then we have hopes equal to hope plus 1. So initially it is 0. 0 plus 1, 1. And then we are exiting the loop. Okay. Now if you observe thing, so here what we have done, we are only check whether there is a age from K to C, and then we are equated to 1, and then we have replaced SK to 0, SK by that particular value 40, and then we exit the loop. Okay, so we have exited the for loop, not the while loop. Remember here what we have done. So this exit loop is what? For the for loop, not for the while loop. So go for next iteration. Here walk is set to true. Again same thing. Walk equals to false. For each C in columns of A, again what we have done, same thing we have to consider here. But the main thing is that we are keeping the count of hopes here. Hopes will be 1 and K will be 4, and what is this? Sum score will be 40. Okay. So from the previous iteration, what we got, K4, sum score 40, and hope is basically equals to 1 now. Now go for the next iteration here. So here for each C in column, say again same thing, start from 0. So 0, 0 not equals to 1. Don't do anything. Go for, okay, sorry, not 0.
4 comma 0, sir.
Yes, yes. Here the value of K is what? 4 here.
So we are going to fourth row, right, sir?
Directly 4th row, and then we are comparing for which column we have this 1, right?
Yes, sir.
So if you observe,
No, here after
No,
the same.
no
Is
columns, sir.
fourth
Four
row,
only.
fourth row zero column?
Yes,
no,
sir.
no. Here the value of K is from the previous iteration, it is 4, right? You understand this one till here? From the previous iteration, what we got? You understand the previous iteration, right? K equals to 4, sum score 40, hope equals to 1. Now for the next iteration, what will happen? The value of K is 4. So this is 4. And now we are checking C. Again, C will start from 0, 1, 2, 3, 4, 5. So for the initial iteration, when C equals to 0, again we are checking 4, 0 is equals to 1. No, right?
No.
If you observe that particular matrix for the row 4, we don't have any one in that because it was a lesser one, right? 40.
Yes.
So anyway, this
It will
condition will
never
never
become
become
true.
true.
Yeah.
If never become true, then we
True.
keep going to for loop. We'll finish till c equals to 5. Then we'll exit the for loop. But if you observe, the walk is false now, right? The walk never get
Yes.
updated here because this condition never become true. So walk is false now, and if I go back to while loop, walk is false, then we'll exit the while loop now. So that's it. So what we have done here? We have just taken hopes equals to 1 for k equals to 4 and s will be 40. So after going through all the pseudocode, we got this value, right?
Sir,
This
I'm
is what.
having a small doubt. How did you initialize s of 0 equal to 50, sir, in the starting? Like,
No, here it is given to us that k equals to 0 initially. So sum score is s of k. So s of 0 is what? 50.
okay, okay,
That
no,
particular
okay,
value.
Yeah.
understood, sir.
For this dictionary, for example. So you can take any dictionary. So after the session, take any dictionary, like any values, and then you can try on your own. Okay, change the sequence. So this is what we got from this particular thing. Any doubt, anyone, what we have discussed here?
No, it's fine.
Okay, so
No,
let's,
sir.
okay, here it is given. Okay, let's see. Let us take an example to see what is happening here. Consider the following table 5. Already sequence number is given to S. So why we take that? Okay. Let us analyze the pseudocode which start equals to K. 0 sum score whole. Hello, obstacle beginning. Okay. In every for each mock is 10. Mock is on the other hand, if no is start a node, if this not okay. Okay. Also the 4 question. Okay. So whatever we have discussed for this pseudocode, how it is working, the explanation is given here. Okay. So instead of this dictionary, what we have considered, consider this one now. Sorry, I didn't read the question. So 70, 150 is the example or what? Hmm. You can take that also.
Hope
Uh,
for this
s-
actually we can say easily hope is 3. First he'll check 70 and it will become again 50. So hope will be 1. Again it will check 6 to 40 it again 1 and we'll fix the 40 and it won't. That's it.
Let's take this dictionary and
Uh-huh.
let's do this again.
Sir, for us, there is no dictionary given, sir. Like, for you, it is given, right? Yeah, it's not given for
Okay.
us, sir.
In the quotient is not given.
Yes, sir. Directly.
Okay, it's a solution PDF. I'm referring to solution PDF. Okay,
Oh, okay.
good then. Yeah. So yeah, whatever we have considered, we can consider this one only. So this is not a part of a question. Let me check the question on the portal.
Yes, they're given the solution only.
Yeah. So they have taken the sample like a demo.
Example, yeah, like
Yeah.
what we take, yeah.
Okay. Question. Yeah. So only pseudocode is given to us, and then we start with the question number 5 directly. Okay. Yeah. Sorry for the confusion. So same example we can consider instead of this one. You can just go through this afterward. So I hope everyone understand why we what we have done it here, right? Hope 1 k equals to 4, SS equals to 40. Now let's look at the question. Which of the following statement about the variable sum score is true, irrespective of the content of the score table? Okay. So it is equals to the score of student 0, and sum score will be what? It will be equals to that particular update to k value for which
Minimum
this
value, sir.
condition is true.
Yeah, the lowest mark.
Yeah. So let's see. It is equal to a score of a student n minus 1 is equal to a minimum score in the table. Is this
Yeah,
correct?
minimum.
Yeah.
Correct.
Maximum score in the table? No. So not correct, right? So option C is correct. So if you observe, if you take any data here, if you take this data also, you can find out that thing only. So, okay, so score is 40, but for which value? When k equals to 4, but k equals to 4 is the lowest one, right? So option C is correct here. What about question number 6? The value of hope is equals to 0. Which of the following statements are true? The value of hope is equals to 0. When the value of hope will be equals to 0? When this
Uh,
condition never become true,
yeah.
right? So it,
So all are 0. The
yeah,
entire
so
matrix and 0. So it
So
is.
initially only we have to take least value to make that possible. No, sir.
Yeah.
yeah, so this will never get executed when this condition is false. This condition will be false when we get 0 for all the values. So in which case we get the 0? We solved the previous question. Question number 3
Every
was solved.
student will get a
Fourth value, sir.
number of equal marks.
Yeah. So student K has scored maximum marks,
No.
minimum marks, right?
Yeah.
Yeah. Student K has scored minimum marks. For that only we got this 0. So value of K is equal to 0. Insufficient? No. Option B is correct. What about C? The value of K is equals to 0. Value of K is equals
Yeah.
to
When
0.
the student scored 0 marks.
Yeah. Sorry. So initially it was 0 only, right? So it never get updated here as well. So value of K is 0 also, right? Because of initialization. Yeah, the value of K is equals to 0. Student K has scored minimum marks. Okay. In that scenario only, we are not going to execute that particular block. So option B is correct and C is also
Sir,
correct.
I missed. Once could you again repeat why k value is 0?
No, initially it is 0 only, right? And we have not updated the value of K. So we started with the initialization K equals to 0, and this is going to get updated here only. And this will get updated only when this condition is true, right? But we are saying that will
Okay,
never become
so we are assuming that 0 is the minimum value now in this
no,
in
no,
that part of the question, like
no, no.
for that
We are
option.
not we are not assuming. Here initially the value of K equals to 0 only. So this will get updated here,
Yes,
right?
sir. Yes, sir.
So this condition should not become true. So for this scenario, yeah, you can say when the for sequence number 0, we have the lowest number, right?
Yes,
This is
sir.
what you are
Yeah,
saying,
that
right?
yes, sir. That's what I was saying.
Yes, that is
For
what
that particular option, we are
yeah.
yeah, okay, sir.
So student K has minimum marks and value of K is equals to 0. Yes, this is correct. Question number 7. The variable hope satisfies which of the following inequalities? So it will be in between 0 and n by 2, 0 and equal to n by 2. Tell me which one is correct.
What is inequalities?
Inequality following this was satisfied. This one, this expression inequalities. So hopes in between 0, like less than or equal to 0, sorry, greater than equals to 0 or less than n by 2. And n is basically what we said 5, 6, right? It is n by 2 is what? 3. So hope is either 0 to 3, like less than 3, or 0 to greater than or equal to 3. What do you understand by this hope? Now, what do you understand by hopes? Tell me.
Sir, after many iterations, it will directly take us to the least value. Like, I guess it's that helps.
Let's try to understand the meaning of hope first. We'll see what is the
When
answer
the
of this.
condition becomes true, it will be updated by that value.
Yeah,
Yeah,
it's transferred data.
yeah. So if you observe here, hope will get increment only when this is true, right? And here you can see hopes plus 1, right? So if you observe, there will be at least one value in a table which will be the lowest, right? And for that particular value, this will never become true. This is what we have discussed from previous two questions, right?
Yes, sir.
For that scenario, this will never get executed. So it means anyway it is less than n. Wait. What is the answer here? What we got? Hope equals to 1 for this particular thing.
Sir, I guess coincidentally, like the zero in the zeroth row, it is becoming one. The value is becoming one for fourth row or fourth column, where
Hmm.
it is the least value.
Lowest. Right.
Like if we consider k equal to one, then at the zeroth column only it's becoming one. So then we can get a proper uh, like before it was a coincidence. So directly we had only one iteration where hop is only updated once. The
Okay.
example
So
which we have taken, I guess there.
let's interchange this. Let's see. We have 50 here, and let's say here we 40. This is 50. What will happen in this scenario?
Sir, we'll bet. So better we'll update k equal to one, sir, because if we change the dictionary, we have to do again iteration. It will be confusing for many people, I guess.
K equals to 1.
One or two, we can any value of k.
Why? 1.
Uh, because in the one we are getting at the zero column only one is updated to one, sir. Like from
Uh,
0 to 1, so that
mm,
we won't get ambiguity of 4
mm, mm. So see,
in the
yeah, let's go ahead.
like in the first like at the in the k equal to 0th row, directly 1 is updated to 1, like the value is updated to 1 at the fourth value.
Yes,
That's
yes.
like a coincidence.
Hmm. Yeah, I got your point. So let's say instead of k, we get consider this as 1. So what will happen here? S of 1 is what? 60 now. Now for each, so walk is initially true, walk is false. C in columns A. So k is what? 1 here, and we are iterating over the value of c. Now when this condition will become true for what value of c, that is equals to 1. So let's say for 0. So do we have 60 greater than 50?
Yes, sir.
Yes, so if this is satisfied, if this is satisfied, k equals to c. C is what? 0. Sum score is what? sk. So here that will be 0, that will be 50. Hope is equals to 1. We exit the loop, go for a next while is true, walk false, c 0. But here k is what? 0. But when c equals to 4, we got this one. So here hope will update to 2, right?
Some score will update to 40, sir.
Yeah, sum score will update to 40. So if I keep doing this, we need to find out what is the range of these hopes, right? So till what value, the maximum value of hopes? Zero hopes will start from 0, that is for sure. Less than or 0, uh,
Sir,
0
I
or
guess for highest value we have to iterate, then we'll get the maximum value of hops, sir. Like for 2, it is the highest
yeah,
value
it
rate,
will get,
80.
yes,
Then 8 will update, that's sorry, that many times where till which it will get to 0.
yeah. Because if we get 4, so after next iteration it will get to 0, right? If we get to sequence number 4. So here hope is 2. If we go for next iteration, in that scenario, the value of what was there? K is equals to 0, not k. What is we have done update here? First one, then k equals to 0. So C, yeah, C is what 4 here. Again, that will be 0, right? So in this case, it's happening here. So what is hope actually? So when I say A, B, and C, so here A and we have B. So if I say I can go to A to C, we have one intermediate station, we have one intermediate node, that is basically one hope, I can say. Okay. So this is what we discussed, I think, in the trains example in the lecture. Okay. But here we are dealing with the variable. Let's see.
So
Yeah. So
take in descending order, sir. First mark is highest, then lowest, then lowest. If you take that, it will come in minus 1.
Descending order. Yes. So anyway,
Yeah, we should check a maximum.
we should start with maximum, and let's say we have 0, 80, 170, 260, 350, 4. Let's say we have just 4, not 40, like this, right? So here what is
Every
going to
time it
happen?
get increased.
Yeah. So if you compare zeroth value with any value, that will be 1, right? Except the 0, except the diagonal element. So in this scenario, what will happen? It will be n minus 1, right? See, so k equals to 0, some score is what? 80, walk true, hope 0, walk true, walk false. C is what? For the first iteration 0. If you talk C is 0, 0. So this is not true for the diagonal one. Go for a next iteration, C equals to 1. We have fixed the value of k, that is basically what? 0. So this is 80. And when we have 1 here, for all the values, because 80 is greater than 70 also, 60 also, 50 also, 80 also, for this condition, it will be 1, right?
Yeah.
Yes, sir.
So here in this case, when C equals to 1, that is true. Value of k is updated to 1. This updated to 70. Hopes equals to 1. Exit the loop. Go for next iteration. Walk is still true. Walk is set to false. Again, C start from 0. But the value of k is what? 1 here. The value of k is 1. Now, for which value of C? It is we have 1. For 1 0.
2.
For 1 0, do we have? For 6 for 70? No. For 1 1 also no. But when C equals to 2, in that scenario, 70 is greater than 60, again true. So we set C to true, this set to 60, this we say 8 to 2. Go for next iteration. Again, here in this case, the value of C will start from, like here, exit a loop. Again, walk is true, again, walk is set to false. C again start with 0. The value of K is again set to 2. For which value of C we are going to get 1 for the first time? 3, right?
Yes, sir.
So 3, in this case, hope will be 3. So in this way, if you go, we'll get the answer n equals to 4. So that is basically not 4, like hope equals
5.
to 4. That is basically n minus 1, right?
Correct.
So
So
for
if we do
this,
it from highest value, sir, it will hope will update till the least value. So
this will till this one. So it will be
n
n
minus
minus
one will
1.
be the
Yeah,
answer.
yeah. So great. What happened? So here if you see question number 7, so it will start from 0 to n minus 1. So option C is correct here, right?
Yeah. That is the
Uh,
maximum possibility.
yeah. Yes, so we execute the pseudocode. Yeah, I think same thing is given here as well, right? In the solution.
Yes, sir.
Okay, that's it. Anyone, any doubt what we have discussed? So please try to solve this question again. Very good question. Your concept will get clear. Okay, so here 5, 6, 7 we discuss. What about question number 8? Which of the following statement are true? Executing the pseudocode given below. So sum equals to 0. For each C columns in A, sum equals to what? 0 plus what is K? K, I think it is in continuation with the 0, 1. What? If we consider this only, so that will be 0, right? So if we start with K equals to 0, and this is C, so 0, 1, do we have anything? No. So we will start from 0, 1, 2, 3, 4. So 0, 0 is what? A 0, right? If we say 0, 1 is what? We got 1, 0, 1. 0, 2 is also 0. 0, 3 is also 0. 0, 4 we got 1. So in that scenario, it will be 1, right? And then if we go for a next iteration, that will start from 1 again. So here we are simply considering the summation of number of times we have 1 here. So where it is the matrix?
So that means hopes.
No.
Just for first
Okay.
row.
is not a hook here. K is 0 only, right? We have to consider. So sum is equals to 0, that is not going to become true. If we see K equals to 0, so if I just take K equals to 0, in that scenario, what this sum will represent? Let's take K equals to 0. So in that scenario,
Only
what is
one
going
time, sir. It will
yeah,
update only once.
for 4 and 5 as well, na? For 5 also we have 1, right?
Sir, you have updated the dictionary, sir. Like, different dictionary, isn't it, from the oldest dictionary?
Old one only. So old we have only 4 4. Okay, only 4
Only
4.
four, sir. Yes,
Yeah,
sir.
so that will be 1. Go for next iteration for C. Okay, we have gone through all this iteration. So C. So K is 0, sum equals to 1, sum is equals to n minus 1, sum is the degree, sum is the in degree of, yes, read the options first. Yeah. So if I take K equals to 0, so we are talking about the node 0 here, right? So sum is equals to 0. No, not true. Sum is equals to n minus 1. I will see. Sum is the in degree of a node K in the graph. So number of, okay, what is in degree? What is out degree? Yes, anyone?
Oh, sir, could you tell,
Degree
sir?
Hmm?
in degree is a column. Out degree, I mean,
No. So it means that no one has watched the lectures, no one has solved the questions, right? So
No, no,
see,
no, sir. We have done, sir. Like,
then what is in degree,
uh,
out
out
degree?
degree is the number of rows, like row value, right? If I am right.
No. So when I talk about the node A, so degree of a node A. So degree of node A is what? In degree plus out degree. Okay. And what is in degree? In degree is what? Number of incoming arrows to that particular node. Number of incoming arrows to that node. So if you talk about in degree of A, we don't have any row coming towards A. In degree of node A is what? 0.
But
But
A
what
has
about,
two out degrees.
yeah, out degree of A is what? Number of outgoing arrow, like away arrow going away from this node A. That is what out degree. So we have 2 here, right? And when I say degree of A is what? Number of incoming or outgoing arrow is what? Degree of A. So here out degree of A is 2, in degree is 0. Tell me about the node B. What is in degree for B and in degree or out degree for B?
1 1.
1 1.
1 1. So in total we have 2 degree. For C, in degree
2 in
is
degree.
2 and out degree is 0, right? This is about in degree and out degree. I hope you understand the concept of degree now. Degree of a
Yes, sir.
node. Simple one. Yeah.
Sir, so can we say that for in the old dictionary, K equal to 2, where we had the maximum value, maximum mark, so the out degree would be at the sum would be at the maximum, right? Like the sum is 4, sorry, 5 written.
If
Can we
I
say
say
that?
K equals to 0, sum is basically 1. Now let's take
Yes, sir.
K equals to 2. What is going to happen? What is the value of sum?
5 I'm getting, sir.
Yeah, we have 6 node, right? So that will be 5, right?
Yes, sir.
Yeah, but how many, what's the degree of that particular node? Which one was that node? Where it is? 2, right? So 2 is what? This one, right?
Yes, sir.
So that will be 5. So if I say this is 2, so we have uh, total 5 degree, right here. But we want in degree or out degree. So 2 to 0. So if I just convert this particular row in terms of graph, so this is 0 node. So we have 2 to 0, we have 1. That will be like this. 2 to 1, we have like this. 2 to 2, 0, no. 2 to 3, we have one arrow. 2 to 4, we have this arrow. 2 to 5. So what is this one? What this represent?
Out
Arrow,
degree
In
of 5.
degree.
yeah, going out. So out degree of that particular node will be that particular sum. So it represent the out degree, not the in degree, right?
Yes, sir.
So let's see. Option C is not correct. It will be option number D, out degree of a node K. So option A and D. Sum is equals to 0. For which node sum will be equals to 0?
So whichever not going out.
For a node having the lowest one.
Yeah.
If you see for this fourth thing, if I take the value
Yeah.
of K equals to 4, sum will be 0,
Everything
right?
0.
Yeah.
No out degree.
No degree. So in that case also it will represent K will represent the out degree, but anyway it is 0, right? So sum is the out degree of node K in the graph, and sum is equals to 0. Sum is equals to n minus 1. No. Yeah. So here I think we should mention we need to consider only one value of K, because for other value it may, here you can see sum is equals to n minus 1 also when I consider n equals to what? The maximum one, right?
Yeah.
So
So this will also be
so we
okay.
have to consider the least value, sir,
No,
to make
here
this right.
something is missing, I guess. We should mention for which value of K, right? This can be true when I take K equals to 4. This will be true when I take K equals to 2, right?
Yes, sir.
Yeah. So something is missing, I think, in the question, but option D is anyway correct, not the C one. So please note the value of variable mentioned in the question represent K of this. We know that K corresponds to score minimum marks in the class. How we know? It is based on the previous question. What?
Yeah. K stores the least marks. Yeah.
Here K equals to 0 previous assumed matrix. No. I think some information we have to give here, right? Because if I take a different K value, answer will be either A or B in that scenario. So K correspond to student minimum marks in the class. This is what we have assumed here. So according to that, that will be a correct one. Okay, but I hope you understand how the pseudocode is working, right?
Yes.
So if value of K, if I take 2, so that will be option B also will be correct. If I take K equals to 4, for our given example, that will be equals to 0. But anyway, it will represent the out degree of that particular node K in the graph. Okay. So this degree concept is clear, I guess. Anyone, any doubt in this question or whatever we have discussed up till now?
Sir, if you could possible repeat why the last question, sir. I couldn't catch up. A
No,
and D, how are they?
no, for A we already. So let's talk about a D first, right? So what they are saying, sum represent out degree of node K in the graph. So what we are doing here for C in columns A, so it is basically 1, right? In the matrix, if you see for K equals to 0, if I consider, so what for which node this particular combination is 1, that is what we are going to consider, right? So for K equals to 0 and C equals to 4, we have a 1 H, or we can say we have the value 1 in the matrix. In that scenario, it will be 1. So value of sum will be 1. But if I take K equals to 2, corresponding value is 80, which is greater than all other value. If you observe in that corresponding row, we have 1, 1, except for that particular second column, right? This is 0, 1, 2, 3, 4, 5. This is second row we are talking about. In that scenario, if you go through for loop, so I fix the value of K to 2, C equals to 0. So 2 of 0 is what? 1. Sum will be 1. Here for next iteration, value of C will be 1. Again, 2 of 1 will be what? 1. But previously sum was 1. So 1 plus 1 was 2. So go for next iteration. Value of C is 2. 2 is 0. So 2 plus 0, 2 only. So in this way, we are going to take the summation of how many times this 1 appear, right? That is basically 5 times, simply. So what this represent? It represent the out degree of that particular node 2, of that particular node K. So out degree means what? Number of arrows going out of that particular node. So this is what we get. If I just draw a graph for this second row here, so from 2 there is edge to 0. So there will be edge from 2 to 0. From 2 this will be edge to 1. So 2 to 1 there will be one edge. 2 to 3 there will be one edge. 2 to 4 there will be edge. So this out degree of this particular node is 5, right? So sum will represent out degree of that particular node 5. If I consider k equals to 0, in that scenario, our sum was 1. But why 1? Let's take this row 0 here. For this 0th row, for which node I can draw H? For 4 only, right? Like this.
Yes, sir. Yes, sir.
Now, out degree is 1 here for this node. So in that case, out degree will be 1. So that's why option D is correct. Sum represent the out degree of that particular node. Okay.
So for if they ask for in degree, it will be quite the same opposite of that, right?
In degree will be opposite of that. Yeah, in degree basically number of arrows incoming to that particular node.
Yes, sir. Understood.
So
Okay, clear,
if
sir.
you see this example, like node where we have discussed, yeah. So here in degree of node B is 1, out degree is 1 because only one arrow is going here. If you see for node C, in degree is 2 because we have 2 incoming arrow but no outgoing arrow, so that's why out degree is 2. So total degree of a node is what? In degree plus out degree. Okay. And here we'll see if something
Yeah.
is missing, because if I take any different value of k, this is also correct, this is also correct.
This is also correct. Yeah.
Yeah. Okay, let's see. So I hope you understand question number 8 now, whatever we have discussed up till now. Now let's go to question number 9. Consider
Sir,
graph.
actually,
Huh?
node means it's actually the particular the value roundabout, right? The node actually what
Node of a
means.
graph is vertices of a graph, this particular one.
Okay.
Yeah.
Yes.
So this is a node of a, so this is a graph, this is basically a node, this is basically a edge, right?
Okay. Edge means it is arrow.
Arrow, yeah, this particular.
So click, actually they're saying about the click something it is we can say
A
that
click
is
is
what
in
I
click is in week 9.
that yeah.
Okay, okay. I will discuss about the click also. Do we have
Okay,
any
okay,
question? Let us discuss question number 9 and 10 first. Yeah.
okay.
So question number 9. So following pseudocode, construct the matrix B from A. What is A? Assume A had already been computed. Correct code to compute the pseudocode. So N is length of the keys. Okay. New question, right? Okay, here it is a graph. So graph G that we worked with the previous two problem. Same graph. Okay. GR is a graph that is obtained in the following manner. So we need to consider that graph what we have considered the question number 2, and GR is a new graph that is obtained the following manner. So given a pair of a student I and J, there is age from I to J if and only if I score is strictly less than that of J. Now B is a matrix represent GR. So if you observe, G represent what? I score greater than J. But what is GR? I score less than J, right? Hello. So we are talking about the this particular graph here, what we got. So where is that? This one.
The second and fourth one.
Yeah, second question number, right? So we have considered the this particular matrix. Here we have considered one for this condition when the score of that particular student, let's say I to J, if only I is strictly greater than that of J. So that is one. But what is GR in the question number 9? I is strictly less than that of that particular
Okay.
J. So what will be a GR by looking at this particular G? Tell me what will be matrix for G? This is A they are saying, and GR and the matrix B correspond to GR. So what will be the matrix B? Yes, anyone?
It will make the matrix in the reverse way. So
Reverse way.
I'll be checking. Yeah.
Rows will
So
be the
if
columns and
if it
columns
is
will be the
greater,
rows, sir.
Huh?
Rows will be the columns, columns will be the rows, if I'm right, sir.
Rows will be the column. column will be the rows. Yeah, that is correct.
Yeah. We are checking if it is greater here, and we are checking less than, we'll be iterating. I mean, mark it as 1. Yeah.
Yeah. So yeah, if we just simply take the transpose of that, that will give me the matrix, right?
Yes, sir.
0, 0, 0. And also, I can say that here, if I replace 1 by 0 and 0 by 1, except for a diagonal element, that will give me the matrix for I less than j, right?
Yes.
We
Diagonal
got 0,
elements.
we got 0 because this condition was true. But we want I less than j, so this will be false. So all the 0 will be 1 except the diagonal element, right? So that is anyway transpose of that. So here will be 1, 1, 1, 0, 1. And if you observe, this is nothing but this particular column only. 1, 0, 1, 1, 1, 0, 1, right? So you can do either one thing. You can take the transpose of this particular matrix. I hope everyone know what is the transpose of matrix.
Yes,
In
sir.
maths 1 we have learned, we will learn in maths 1 or maths 2. So simply
Mass.
interchange the rows and column. Yeah. Either transpose or simply you can change whenever there is 0 in this matrix, change to 1 and 1 to 0 except the diagonal elements, right? So that will be a matrix B. So that will be a B is a matrix for GR. Consider the following code to construct the matrix B from A. Assume that A already computed. Okay, let's see. We need to construct matrix B. So that will be again a 6 by 6, what we have considered. For each I rows, for each j in columns, we need to fill the code. Yeah. So tell me, what about the option number A? When I say B of ij will be equals to A of ji, what is this? Is this true?
No, true. False.
Why false? We are
Okay, we took
saying that,
reverse here.
yeah, when I say if I to j, so whenever this age from I to j, we are saying i's marks is greater than j, right? And now we are reversing that. We are saying ji, and here it is I to j. If I took the reverse, j to I for the same j and v value, so here we can say for this condition, when j is less than I, we have j to I, right? So we
Mhm.
simply we are changing the rows and columns here as well,
Columns.
right?
Yeah. Correct.
So option A is correct here. What about this one?
Yeah, that also correct.
Same thing like above one. Simply we are changing the rows and columns. Instead of j, we have I. Instead of I, we have j. So if you
Sir,
now,
I couldn't catch, sir. Once again, could you uh, repeat?
okay, so the question is saying A is a matrix that we got from the graph G, right? What we got from the graph G that we discussed in question number 2. B is a matrix we got from graph GR. Where is GR? Yeah, so here you can see B is a matrix that represents GR. What is GR here? I
It is
score
the
is strictly,
transpose.
yeah, I score is strictly less
Okay.
than of J, and A is basically I score is greater than that of J. So B is basically transpose of A, right?
Yeah, correct.
If you understand this one, then how what is transpose? Simply we are interchanging rows and columns. So both option A and B is doing the same thing. Instead of ij, we have ji. So again, interchanging rows and column. Here also instead of bji, simply ij. So same thing here, right? So we are interchanging the rows, column, and here in both the options. So option A and B both are correct. What about C?
False.
If ij equals to 0, then you're updating to 1. I
Ij
said
can be a diagonal amount also.
yes, yes. So this is going to consider the diagonal element as well. That's why it is false. Okay. Diagonal element as well. So that should be equals to 0 for diagonal elements, right? So
Yes.
in this
So
scenario,
we should
this
not
is
change for diagonal elements, right, sir?
Yes, yes, we should not
It will
change.
always zero. Yes.
diagonal element will be a 0 because it will be like this when the score of I is greater than or equals to I. But that anyway not possible, right? We are not saying that. we cannot compute the same thing. Greater than or less than. When I say equal to or less than equal to, in that scenario,
Then
that
it's
can be true.
possible.
Yeah. Okay. So option C is not correct. What about D? Same thing here as well. Okay.
Yeah, same only. Correct.
Yeah. Because of diagonal element. What about E?
False. Because we are not changing anything. Okay.
Yeah. So if the value of ij is 1, then we are subtracting from 1. If the value
1
of
minus.
yeah, so 1 minus 1 will be 0. If it is 0, then it will be 1, right?
Yeah.
So this is also correct. Instead of 0, we need to replace it 1, and instead of 0, it should be 1. Instead of 1, it should be 0. Because of
What
condition.
happened then diagonal?
Diagonal element is what? We are not talking about diagonal element I and j, right? So here I and j, I and j.
Okay. Okay. Same row, same column. Yeah.
Yeah, so same, no different column, right? So E will also be correct one, A, B, D.
Sir, sorry, but actually I'm unable to understand that in E option, why aren't we considering diagonal?
Yes, sir.
So
Could you,
please.
sir, could you repeat E option, sir, once again?
See, for B of ij, we are saying 1 minus this particular thing. So when I say I, j, so here we have one arrow. It means that in a particular matrix, we are saying A of ij is equals to 1. And this will be 1 only when the marks of I is greater than j, right? In the case of matrix A. Matrix
Yes,
B,
sir.
what we want, when the I is less than j, in that scenario, B of I, we want j. That is equals to 1, right? So
Yes, sir.
this is what we want in the case of B of ij. So B of I and j equals to 1. So if I, instead of 0, but what about the diagonal
Yeah,
element?
diagonal only it is matters, right? Ij, if it is 0 and 1 minus 0, again it will show 1. It
Yeah.
should be 0 only, no?
Yeah, for diagonal element, it should be 0. But if I take I and j both I, here also I, so this will be 0,
1
but that will
minus
get updated
0.
to 1. Yeah,
1.
yeah.
That's it wrong.
So
That's what I said.
yeah, yeah. So if you where it is, where we have drawn, yeah. So this is the matrix A, right? But what is B? So whenever there is 0, we want it 1, and instead of 1, we want 0, except the diagonal element. Because for diagonal element, this condition is not true, right? It is less than. Or we can simply take the transpose of that. So the row will become this particular column. So 0, 1, 1, 1, 0, 1 will be the my next row here, first row here, like this. Either you can take the transpose, or you can simply change 0 to 1 except the diagonal element, or 1 to 0. Yeah, so option D will, sorry, option E will not be correct, because it is going to update the diagonal element as well. But why they have mentioned option D also correct? Okay, it is j of I here. Yeah, here it is I of j. Okay. Okay, first thing, why option E is not correct? Everyone got right? For diagonal element, that will get updated to 1, but we don't want that, right?
Yes,
Hello?
don't want to.
Yeah. What about D here? Here it is ij, here it is ji. So when I say j to I is equals to 1, we are updating I to j to 1, right? Here,
Yes, sir. Here,
we
there
are
is no chance
not
for.
consider diagonal element, because this will get satisfied for diagonal element, right?
Yes, sir. Yes, sir.
Here it is no chance. Yeah. So whenever there is j to I1, we are updating it to I to j to 1, right? So this will
We are not
be a
touching
correct
the
one.
diagonal.
No, no. Diagonal will be possible only in this scenario when I and j both are equal, and that is 0, right? But here I and j, we don't have that condition of 0, right? So we are not checking for diagonal element here at all. So
Yes,
anyway, that
yeah.
will not be true. Yeah. So this will be true for non diagonal elements, and here you can see we are updating it to 1. So option D will get update here.
Yes, sir.
Okay. So if
Sir,
I,
could you once again go for option E, sir?
yeah, so let me write down the small matrix here. Should be one row, sorry, one row, that must be 0. So let's make it 0, right? Yeah. So let's say, so here 0 to 1 means what? Score of, we are talking about a matrix A. So score of 0th row is greater than the score of the first one. And here the score of, no, that is not correct. So this will be, if I update it here, so it means that score of 0, wait, 0, 20, 1,
So it should
30,
be, sir, 0, 0, 1 and 0, 1, 0 and 1, 0, 0, no?
no, we'll see. Let us take a small
Hmm. It should be
dictionary.
unitary matrix, I can remember, which we have studied in class 12th.
Unitary matrix, we'll see, no. See, let's take for this S only, right? Instead of going back again and again. So this is the matrix. So this is the graph G, matrix A. So 0 to 0, 1 to 1, 0 to 2. So 0, 20, greater than 30? No. Greater than 25? No. So lowest one, 0. What about 1? Greater than 0? Yes. Greater than 25? Yes. What about 25? Greater than 0? Yes. Greater than 1? No. So this is the matrix G for graph G and for adjacency matrix corresponding graph G. But what is B here? B here is what? If I say I is less than J, and we got this for I greater than J. Now let's draw a matrix for B here. So 0, 1, 2, 0, 1, 2. Again, diagonal will be 0 because this condition will never become true for diagonal element. Now I is what? 0 first. Now what about 0 and 0? So 0 is not greater than 0, like score for corresponding two values, key 0. Now what about 0 and 1? So 20 is greater, sorry, 20 is less than a 30. Yes, right? So that will get updated to 1. What about 20 less than 25? Yes. What about the 1 now? First row, 30 greater than, sorry, 30 less than 20? No, that will be 0. 30 greater than, sorry, 30 less than 30? No, that will be 0. 30 less than 25? No, again that will be 0, right? What about 2 here? 25 less than 20? No. 25 less than 30? Yes. 25 less than 25? No. Now this is my matrix B for a graph GR. This is my matrix A for the graph G. Now tell me, what is this one? Like, did you understand what we have done here? Here we said S of I is less than S of J, and here we say S of I is greater than S of J. Okay? Hello?
Yes, sir.
Yes,
Yes.
Yes,
sir.
sir.
Yeah. So this is the matrix B, this is the matrix A. Now check the condition here. Now when I say Bij equals to Aji, so take any two thing I. So for B of I and for J of 0, so 1, 0. So it is equals to 0, 1. So 1, 0 is what? 0, and 0, 1 is what? 0. Yes, it is true. So this is true for all the values here. So if you take I 0, J 0, here also 0, 0, that is anyway true. All the diagonal elements are true. Right? So option A is correct. Now any issue with the option number A? Anyone?
No, sir.
So with this, can we do option D also once? It will be more clear.
Option B or D?
No, sir, D. D.
Yeah, D, I will come to that D. So similar for B as well. B of 0, comma 1, that is equals to 1, A of 1, comma 0. Same thing like what we have discussed, option number A, both are the same thing. So A and B are correct. Why C is not correct? See here. If Aij equals to 0, what we are saying, if this condition is true, then only we are updating B of I j to 1. But what about this particular diagonal element here? When I say I is 0 and j is also 0, in that scenario, this condition will become true. So this will be true. If this is true, then I'm going to update B of 0 and 0 to 1. So this will get updated to 1. I don't want that, right? This is not possible because score is less than j, so we cannot compare 20 with 20. That is not true. So that's why option C is not correct. Any doubt with the option number C? Anyone?
No, sir.
No, sir.
No.
No, sir.
Now let's go for D here. If J of I equals to 1 for the matrix A. So when I say J of I, if A of, let's say, 1 and 2, if A of Ji, so here J is basically 1 and I is basically 2. Now this equals to 1. So here 1 and 2. So 1 and 2 is 1. So that is 2. If this is true, then we are going to update to what? B of Ij to 1. So B of Ij. Now what is I? 2 here, and what is J here? 1. So we are updating it to 1. So 2 and 1 is got 1. That is correct here. So we are updating whenever there is 1, we are updating it to 0. Okay. And whenever we have 0, we are not checking for that condition if you observe. Even I and J, same value 0, 0, but that is not basically equals to 1. This condition is false. This will be 0, right? Here, here, here. So we are not going to update that. So option D is correct here. Okay, any doubt now? Anyone? Someone was asking about option number D. Did you get this one?
Yes, yes, sir.
Yeah. So yeah. Because here diagonal elements are not being considered because this condition will never become true for diagonal elements. Okay. Now what about option number E? So B of ij equals to I or 1 minus A of ij. So let's take this one I1 J1. So B of 1 comma 1 is equals to 1. Please mute. So 1 minus A of 1 comma 1. So 1 1 is 0. So 1 minus 0 is 1. But it is going to update the value of a diagonal element. This is what we don't want because that is not possible. So option E is not correct. So A, B, D are the correct one. Now anyone any issue with this one?
Sir, instead of diagonal, like if we take any other option E, then it will be right only, right?
Yeah, it will
Like
be right.
no.
for the-
Okay, so that done, sir.
But see here. Yeah, that will be correct. But for diagonal, it will not be correct.
So, sir,
What?
here is the main thing is we have to use first transpose of the matrix.
No, this is what it is given here. So what is
Hmm.
GR is? GR is basically what? In the following manner. So I scores strictly less than of J. And B is a matrix for corresponding to that particular graph GR. And A is I greater than J. So if I take the transpose, I will get that particular matrix, right? For this question. Okay.
Hmm.
If I simply change greater than equal to in that scenario, that will be a different one. Okay. Here I'm saying greater than equal to, and here I'm only saying less than. So that will be a different scenario. In that case, transpose will not work. Okay. Because if I consider this one, diagonal element will become 1. And here we want strictly less than that of J. So in that case, diagonal element will be 0. So transpose will not work in that case. So for this condition only, where in the case of matrix A, greater than, in the case of matrix B, less than. In any one of the case, if equal to sign came, then transpose will not work there. Okay. Okay. So this is about the question number 9. Now question number 10. So based on same thing for a pair of ij, if ij equals to b of ij. So here we are saying both the matrix we have the same value. Now what is the observation? Evaluates to true. So which of the following statement evaluates to true as the dictionary represents in the previous question? S of I equals to S of j. Can I say this one?
Yes, sir.
So
Diagonal
this
elements.
is true is given to me here. Can we say this every time?
No, sir. For every time we can't say. Only for diagonal elements we can
Only for
say.
diagonal element, this will be equal, right?
Because yes, sir. For other elements, it'll be 100% wrong because we are taking transpose of them.
Options is S of I is equals to S of J. What this is saying. So this will be equal either for like 0 in both the matrix, right? So that is possible when we are comparing with the diagonal element. But here we are saying S of I is 0 equals to S of 0. In that scenario, that will be true, right? Diagonal means what? I equals to J only, right?
Yes, sir.
correct.
And same marks. So this will be true in that case. What about non-diagonal thing? We are saying evaluates to true. So this expression is true. Now, if this is true based on this, we have to answer. Now, this will be true when for diagonal element only. Otherwise, is that possibility that that will be true?
No, it is not possible.
No, sir.
Not possible. Okay. What if I take this one as 20 again? In that
Yeah, then
scenario,
it is possible now.
yeah, for 0 to 2, 0 to 2, that will be 0. And here also that will be 0, right? So now that
So we need to
both,
get duplicates.
yeah, duplicate. It means that for same S of that value. Duplicate means what? Value only, right? Here we're talking about value only.
Yes, sir. Yes, sir.
So option A will be correct, right? In that scenario. Either you can go for a diagonal element, still it will be correct. But this is only possible when it's diagonal element or we have two sequence number having same marks. For example, this one, right? In that scenario also I 0, J is 2, but the score is same, right? So in both the matrices it will be 0 and the score is same here. So option A is correct here, right? So whenever the score is same, for that case only we will get this particular condition to be true. So that's it. What about B? Not correct. C not correct. D is no. Only option A is correct here, right? Okay. Anyone any doubt in this question? Question number 10. Why option A is
Sir,
correct?
I'm having an ambiguity. Like, it is not always true, right, sir? S1 equal to Sj. Like,
No, this will be
only when only for diagonal elements and the same score elements only, right?
yes,
For the
yes.
others, it will be wrong, right? Then we can't
Others it will
say
be wrong.
like we can't say no, sir.
No, no. Here we are saying evaluates to true. So we are assuming that this is true. Now this is true for what condition, right? Now this will be true only for this condition as well, right? We are checking for which condition this will become true. The following expression evaluates to
Okay,
true.
understood, sir. Okay, now I got it, sir.
Right? So this is true for which condition? That is what the question is. So in this scenario only, we will get this particular thing. Okay. So that's it. We have solved all the question 10. Now what is click? Yes, anyone? What do you understand by click?
Sir, click in a click. If it is a click, then every uh, there should be an edge to each and every element, sir, from one node. Then it's said to be click, sir.
Yes.
They all are related to each other.
Yeah. So in a particular graph, a node should be linked to all the remaining nodes. So for if I take a click for this three node, so A is linked to B, A is linked to C. If I draw this one in the case of undirected graph, so B is also linked to A, C is also linked to A. Sorry, A is linked to both the nodes B and C. B is also linked to both the node A and C. C is also linked to both the node A and B. So in this particular graph, this is a click. Okay, so this is a click of three nodes. What about the click of two nodes? Is this possible? So A is linked to B and B is also linked to A. That is also possible. This is also click of two node. What about the four node A, B, C, D? Tell me how click is possible. If I draw like
Three.
this, whether it will be a
Two
click or
diagonals,
not.
sir.
2D will be 2C also.
So here it
B,
should be like this.
D, C. Okay.
So I have two graphs here. So first one is this one, second one is this one. So if you see in second graph, A is linked to B and C, but not to D. So I cannot say this is a clique. In the clique, every node should be connected to all other nodes. So what is clique? Every node in the clique, every node must be connected to all other nodes, right? All other nodes. So if you see for this particular graph, A is not linked to D, similarly D is not linked to A, so this is not a clique of 4 nodes. But if I draw a graph like this, A is linked to B, C and D as well. Similarly, D is linked to C, A and B as well. B is also linked to A, C, D as well, right? That is the concept of clique here. So every node must be connected to all other nodes. So that's the concept of clique. Anyone, any doubt now about this one? Simple concept.
Yeah, same kind of question. I understand this, but activity 9.6, third question. Uh, so that is I don't understand something that
9.6. Which question?
9. Third, fourth, fifth, all are same question only. Uh,
Okay, anyone, any doubt in whatever the question we have discussed up till now for practice assignment? Or any doubt in week 9? No.
Sir, 9.26 question, if you can solve, please solve.
So let's take 9.6 first, then I will go to 9.2. Okay. So this is the
Oh,
question, right?
okay, sir.
So the information given to us, so noun, pronoun, article, adjective given to us, 3, 4, 5. Choose the correct graph between noun and pronoun based on the concept in the lecture. Okay. Noun and pronoun.
so as a word data set. So from the first 0 to we can map it to 4 and 5.
What is discussed in the lecture, like it's based on
No,
that
no,
or
like
what?
same like whatever the thing is like noun to pronoun. So
Okay.
it is already given in that word paragraph above. So word biasm is the no, biasm is not that one. Use the
Bias is just with,
information.
okay.
Yeah, this one they're
Information.
considering here. So the 0 will be mapped to 4 and 5.
0 will be mapped to 4 and 5.
Okay, and 6 will be mapped to which is mapped to 11, 12, and 14.
0 will also map to pronoun also, right? Between 9 and
Yeah,
14.
correct.
So
Yeah,
0 will map
correct.
to 4, 5, 6, 11, 12. So
Correct.
4, 5, 6, 11, 12. What about 14? 14 also, no? So option A is correct.
Yes. No, option A is wrong.
Okay, we'll see.
Option C will be correct.
What happened? Why option A is not correct? Why C?
Uh,
0, 4, 5, 11, 12, 14.
because
Okay.
which is
Uh,
pronoun and which is not connected to other elements.
right. So 0 to 6 is what? For noun. So noun to noun, they have considered different node. So 4, 5, 11, 12, 14. 4, 5, 11, 12, 14. And for pronoun, it's this
It's
one
the
and
6 and it is, yeah, we
11.
have to map it to 0 and 11, 12 and 14.
Hmm. Okay, what is your doubt in this question?
The next question, sir. So this is the base question. So understand the next question I don't understand. The maximum size of click appeared in the answer of question number 3. I don't understand what is the maximum size of a click here.
So how many clicks are possible here? So if I take 0, 6, 14, that is one click.
Which is mapped, 0 is mapped to every element. Okay, 1.
0, 6, 14 is one click. 0, 6, 11 is another click. 0, 6, 12 is another click. So here we have three clicks, right?
That is also where we are finding 3.
0, 6,
Like,
and 11. So if I take this 0, 6, 11, this particular subgraph, so 0 is linked to both 6 and 11. The 6 is linked to both
okay,
0. This one click. 0, 6, 12 also, you can see this, it will form a click of 3 node.
yeah.
But said 0 it is not directly connected to.
So connected 6 as well as 12, right? Similarly for 11 also. Click of 3 node we are talking about. 0, 6, 11, 0, 6, 12, 0, 6, 14. There's a click of 3 nodes here, right?
Yeah.
If I take these 3 different rectangles, 0, 6, 12, 0, 6, 11, 0, 6, 14, right? So that will be
Mhm.
a click of 3 nodes.
So it is a maximum they are asking.
Yeah, so maximum
Maximum means
number of
what should
click,
we do?
number of clicks, right? Maximum size of click appears in the answer of question number 3. Maximum size of click, okay. Not number, size. So here I have a size of 3 nodes, okay. Only 3 nodes I can link to all other 2 nodes. So here you can see 3 nodes. If, for example, 5 is also 11,
Then
if I
4.
go,
Yeah. Then
yeah,
it is be 4 because 0, 5, 6, and 11.
hmm. And
Yeah.
5 and 11 should be connected in that scenario. So we can say a click of maximum size of 4. If we have age from 5 to 6 and 5 to 11.
5 to 11, how it is possible? Click of 4.
No, 5 to
If-
11. So 5 should be connected to every other node. If I take 0, 5, 6, 11, that will form a click, right? Let
Okay.
me take the
Okay.
screenshot here.
Correct. 0,
Yeah, sir.
0 map to 4.
We have to see from a different angle. 1105.
Yeah, even but 5 and 6 should be connected and 5 and 11 should be connected. In that scenario, we can consider this as a click of size 4,
Sir, we
where
can say
4
that
nodes are,
port 011 is a click.
4, 0.
Port 0.
No, that is not a click. 4 and
No,
11 is not
click.
connected here. Let me take the screenshot of this one. Is this visible?
Yeah.
Yeah.
So we want size of the click, right? So here you can see 0, 6, 11. This is one click. 0, 6, 12. Another one click. 0, 6, 14. Another click. But only 3 nodes are involved in this, right? So maximum
Yeah.
size is 3 here. But what I am
Yes.
saying, instead of this one, if I have 2 like this, so in that scenario, if I consider this 4 node, so that will connect it to every other node. So size of the click will be 4, maximum size of the click, because 4 nodes are connected then in that case. If I have this two things, right? Even if I take 0, even if I take 0, 11, 6, 12. So 0, 11 connected, 11, 6 connected, 0, 12 connected, 12, 6 connected, right? And 0 and 6 is connected based on this graph only, right?
Mhm.
But if you observe, 11 and 12 is not connected here, right?
Connected.
If this is
Yes.
connected, then I can say it is a node of size 4. Okay. So
Okay. Each node has to be connected by n minus 1.
yes, n minus 1. Yeah, that is also correct. Yeah. And in the case of click, every node has the same out degree. Sorry, degree of a node is same also. So 3 degree, 3 degree, 3 degree, 3 degree, right? N minus 1 degree. That is also correct.
Mhm.
In the case of click, every node has the same degree.
Okay.
Yeah, that
And
is
the next question also same sub question is there. Just simple only.
only 2 questions are there. No?
Now, how many clicks of
How
size
many clicks
3
of
are
size 3 are present? So 3 only, what we discussed. 0, 6, 12, 0, 6, 12, sorry, 0, 6, 11, 0, 6, 12, 0, 6, 14.
Okay,
Three
okay.
triangles, right?
Yes, yes. 3 triangles only.
Okay. 9.2 or 9.3, someone has asked.
Sir, no problems. I'll ask on Monday, sir, because time is up, right?
Okay, no issue. You can ask, not an issue.
No, sir, we are having another class.
Okay, okay. Great.
That's the time will be
So
till there.
that's it from my side. Next week we'll be having the revision session. So Monday, week 5, week 6 we'll discuss, or if you have any doubt, you can ask. Then uh, Friday we'll discuss everything. Okay, and
Revision session, right? Friday.
Friday, yeah. So Monday, week 5, week 6. Friday I will take week 5 to 8. Okay, and
So
on
like any
Thursday we have
PYQ.
a pre-YQ. We will discuss mock questions, so that will be easier. So mock test basically previous year test only.
Yes, yes. That is on Friday, right, sir?
Yeah, Friday we'll discuss. Yeah.
Okay.
Okay. Thank you.
Thank you,
Thanks
sir.
for the sessions.
Thank you, sir.
Thank
Thank
you
you so
so
much, sir. Thank you.